Hello and welcome to Algebra 2 with Mr. Clausen. Today we are going to conclude the third unit of Algebra 2 by talking about real-world three-variable systems. And what I want to talk about today is just an example looking at a real-world problem that contains three variables and how we can go and set this up. So without further ado, I'm going to get started here. So specifically what I have here is a question that says a stadium has 49,000 seats. The seats sell for $25 in section A, $20 in section B, and $15 in section C. The number of seats in section A equals the total number of seats in sections B and C. Suppose that the stadium takes in $1,052,000 from each sold out event. How many seats does each section hold? Right, so in this given situation, I see that the stadium, the total number of seats, is equal to 49,000. And with those seats, there are three types of sections: section A, section B, and section C. And so we're just going to keep those variables as is. So if you have, let's say 20,000 seats in section A, 20,000 seats in section B, there would be 9,000 seats in section C. And this is going to be our first equation that we can use in our three variable system. All right, and we can take the total number of seats in terms of the consideration to take place. And we get that just from this first sentence. A stadium has 49,000 seats. And we can use that to go and extrapolate this piece of information. Most word problems, at least in your Algebra 2 textbook, are going to ask you to extrapolate a equation from each sentence, or maybe the combination of two sentences. All right, and so now I see that seats sell for $25 in section A, $20 in section B, and $15 in section C. All right, and so what I'm going to look at here is I'm going to look at the profit from sold seats. And what I see is that from each seat in section A that I sell, I make $25. So I'm going to go 25 times A, right? And that way, however many seats in section A that I sell will be multiplied by $25. The number of seats sold in section B will be sold for $20, and the seats sold in section B will be sold for $15. But I don't have right now in this sentence the information I need to go and find the remaining information here. So if I go and connect these two pieces, this information will be used here so far. Now, with these type of systems, I also will take into consideration any ratio or proportion that's given. So ratio or proportion. And I am told that section A equals the number of seats in sections B and C. Maybe I should make that a little more obvious there. All right, and so I'm told that the number of seats in section A is equal to the number of seats in section B plus C. And it says, suppose the stadium takes in $1,052,000 from each sold out event. That'll be used over here to tell me that if I sell all of the seats, that I now have this equation that's created. Now, given this circumstance, I now have a three-variable system of equations, A, B, and C being my variables, and I have a system representing the total number of seats, the profit sold from those seats, and the ratio and proportions given to me in the problem. And now the question asks, how many seats does each section hold? So I need to find a solution for A, B, and C that satisfies all three of these equations, because if it does, then I know the number of seats present in each. Now, what I want to take into consideration here now is ask, what type of method should I use to approach this problem? Should I use elimination or should I use substitution? And generally, elimination is a very common go-to method that I like to use. I just get everything set up so A's and B's and C's are in a column, equal sign, and then the constants that are associated, and I just start eliminating like variable A and then going on from there. But one thing that I want to point out is even though elimination might be my go-to method, if I see an easy substitution to use, I'm not going to turn it down. And the easy substitution I see is the ratio or proportion that I am given. So based on this, I am actually going to use this for my substitution into the other two equations. So I'm going to label 1, 2, 3. And so based on this given situation with equation 3 being A equals B plus C, I'm going to start substituting this in, and we're going to see what we can get to, because we already have a nice ratio or proportion already identified here. So what I'm going to do is if I plug, let's say, A is equal to equation 1. So let's plug equation 3 into equation 1. So what that'll give me is that'll give me B plus C plus B plus C is equal to 49,000, and then we could go and we could substitute that in and then say 2B plus 2C is equal to 49,000, and then easily find that B plus C is equal to 24,500. Now, what I want to point out here, though, is if you get to this situation and then you see that B plus C is what this equation equals, we already know that A is equal to 24,500. And if you identify this, you can save yourself a whole bunch of work and not have to do all of these other steps that we've done with other three variable systems. Now, if you don't catch that right away, there's no harm done. The next step would be is to substitute equation 3 into equation 2 and then plug everything in. And then what you would get is something like 45B plus 40C is equal to your 1,052,000, and so on and so forth. And then you could go and apply this equation to this equation using elimination and then figure out what B or C is, and then solve it accordingly. But since I caught this right away and I saw that A is equal to 24,500, I'm going to plug that value directly in to equations 2 and 3. So what I'm going to do now is I'm going to take equation 4 here, and I'm going to plug that in directly into the equation that takes into consideration the cost of the stadium. All right, so I'm going to move on and give myself a little bit of space here and do this. So if A is equal to 24,500 seats, and I plug that into the equation that took into the profit of the stadium, I could go $25 for Section A tickets and plug in my 24,500 plus 20B plus 15C. This would equal my 1,052,000. And with a little bit of rearrangement, I could get that 20B plus 15C. If you you multiply these together and subtract it to the other side, you'll get that 439,500 as a new equation. And I'm going to set this now as my new equation. I'm going to set this as equation 6. Because technically B plus C should also equal 24,500, which we had from before. Okay, so if we say that equation 5, for example, from our previous data, that B plus C is equal to 24,500, what I'm going to do is try to eliminate one of these two variables in question. So I'm going to take equation 5 and I'm going to multiply that by negative 20. Okay, just strategically picking my point. And so that'll give me negative 20B minus 20C And if I take 24,500 and I multiply that by -20, that'll give me -490,000. Using elimination, just solve accordingly. These guys will cancel. I have -5c. Do a little math. That'll give me -50,500. Divide both sides by -5. And very quickly, I will see that c is equal to 10,100 seats. I can plug that into this equation here and find that b is equal to 14,900 seats. And now with all the pieces of information together, if I make A, comma B, comma C my order triple, my combination for the seats present would be 24,500 for section A, 14,900 for section B, and 10,100 for section C. A, B, C. So with that said, hopefully this video gave you a quick synopsis of how to apply 3 variable systems to a real-world example and showed you how to look for specific pieces of information, like when to use substitution and identify little shortcuts along the way that can make these problems solve themselves much more quickly. So with that said, I'm going to leave you to it, and let's do some math.